Assalamualaikum warahmatullahi wabarakatuh to all my fellow friends and teachers. Today, we three Amanah would like to discuss about the given topic, which is the part of physics topic, base quantities and derived quantities. For your information, all the quantities that can be measured is called physical quantities, such as mass, length, time, and temperature. Physical quantities is the process of numerical magnitude and the unit in which is measured. Thus, physical quantities is divided by two, which is base quantities and derived quantities. So, without waste any time, let us proceed to the explanation described by my friends.
Okay, so basically physical quantity is a quantity that can be measured. For example, a length. Let's say there is a 7 centimeter ruler. 7 centimeter is something that can be measured. So it is a quantity that can be measured. So length is a physical quantity. But length is not the only one of physical quantity. There is many more. For example, length, one of it, mass, time, temperature, electric current, light intensity, volume, and many others. Okay, so physical quantity commonly measured of natural non-living object. Physical quantity also have numerical magnitude and unit. Okay, let's say my height is 175 centimeter. 175 is its numerical magnitude and centimeter is its unit. If you want to know, physical quantity also consists of some mysterious thing. If you want to know, you have to keep watching because the person next after me will tell you what is it about. Okay, keep watching.
Base quantities. Basically, base quantities are physical quantities which cannot be derived from another physical quantity. In other words, it is not defined in terms of other quantities, and it is not defined in two or more physical quantities. The physical quantities, units, and symbols are chosen by the SI, which is International System of Units. However, base quantities can be expressed in terms of other quantities. Why? I give you an example. The base quantity length L can be expressed in terms of square root of the area A of a square, and that does not make length, which is base quantity, become a derived quantities.
Next is derived quantity. Derived quantities are quantities that are calculated from two or more measurements. They include area, volume, and density. The area of a rectangular surface is calculated as its length multiplied by its width. The volume of a rectangular solid is calculated as the product of its length, width, and height.
So now I will tell you guys the example of derived quantity. So the first one is pressure and stress. The name is Pascal. The second one is work, energy, and quantity of heat, and the name is Joule. The third one is power and radiant flux. The name is Watt. And the last one is electric charge and quantity of electricity, and the name is Coulomb.
You may be wondering what is the relation between derived quantity and base quantity. Derived quantity and base quantity are related through a formula where derived units and base units are related. Let's take a look at the example. The first one is volume, where the formula of volume is V equals to L cubed. So in terms of base quantities, V is equals to L multiplied by L multiplied by L. The next one is density. The formula of density is P equals to mass over volume. So M is the base quantity, which is divided by V, which consists of L multiplied by L multiplied by L. The third one is velocity, where the volume of velocity is V equals to L over T, where L and T are both base quantity. So the last one is charge, which the formula is Q equals to L times T. So as we all know, L and T are both base quantity.
Prefix. Prefix is a group of letters placed before the root of a word. It used to simplify the description of physical quantities, either it's very big or very small.
Okay, next, the scientific notation for derived quantity. First area, the SI unit is square meter, volume cubic meter, speed and velocity meter per second, acceleration meter per second squared, wave number reciprocal meter, mass density kilogram per cubic meter, specific volume cubic meter per kilogram, current density ampere per square meter, magnetic field strength ampere per meter, amount of substance concentration mole per cubic meter, luminance candela per square meter, mass fraction kilogram per kilogram, but it can also be represented by the number 1. Okay, then the SI base units. First, length. The SI unit is meter, mass kilogram, time second, electric current ampere, amount of substance mole, thermodynamic temperature Kelvin, luminance intensity candela.
So in conclusion, we always apply the physical quantities, either base quantities or derived quantities. And there are also relationships between base quantities and derived quantities. I hope you enjoyed this video. So that's all from us. Thank you very much for watching this.